the final part of ISRO VSSC Electronics Engineering Technical Assistant previous year question paper with a detailed solution. The exam held on 2019. Up to question number 60 we discussed in the last 3 videos. So consider question number 61. What is the maximum power that can be transferred to a load from a 20 volt RMS AC voltage source with an internal impedance of 4 plus 3 J ohm? Answer is option D, 25 watt. The maximum power transfer theorem in AC network is confined to real power P in watts. That is the resistive part of the load network. Here, resistance and reactance both are independently controllable. We can compensate for the net reactance to 0 and the circuit operates at a unity power factor. That is balancing both magnitude and phase. Pmax occurs in the load if the load impedance is a complex conjugate of the source impedance. That is ZL equal to ZS conjugate. Given source voltage Vs equal to 20 volt RMS and source impedance is 4 plus J3 ohm. For Pmax, impedance of load should be 4 minus J3 ohm. Therefore, the maximum power transferred is Pmax equal to Vs square divided by 4 Rs. So, substitute the values of Vs and Rs, we get Pmax equal to 25 watt. Question number 62. The angle of elevation of a tower 120 meter away is 30 degree. Find its height. The answer is option C, 40 root 3 meter. Given that angle is 30 degree. So tan theta equal to opposite side by adjacent side. From the figure we know tan theta equal to height of tower divided by distance. We know the value of tan 30 equal to 1 by root 3, which is equal to height of tower divided by 120. We need to calculate the height of tower. So rearranging the equation we get height of tower equal to 120 divided by root 3, which we will get answer 40 root 3 meter. Question number 63. In a digital communication, intersymbol interference ISI is a form of distortion where one symbol interferes with subsequent symbols. An eye diagram is used to study the extent of ISI in a communication channel. Which of the following is false? Out of the 4 options, option D is the false answer. That is, band limiting the channel helps to reduce ISI. Intersymbol interference is a form of distortion where one symbol interferes with the subsequent symbols. ISI causes due to the spreading of pulse width beyond its limit. Due to ISI, decision device shows error at the receiver. A major cause to arise ISI is multipath propagation and transmission of the signal through a band-limited channel. ISI can be analyzed with the help of an eye diagram. Question number 64. The bandwidth of a video signal is 4.5 MHz. The signal is to be transmitted using PCM with 1024 quantization levels. The minimum bit rate required for transmission is option A, 90 Mbps. Answer. For a minimum bit rate, the modulating signal must be sampled at the minimum sampling rate, that is at the Nyquist rate, Fs equal to 2 FM, where FM is the maximum frequency present at the modulating signal. Here given L equal to number of quantization level equal to 1024 and FM is 4.5 MHz. Therefore, sampling frequency Fs equal to 2 FM. 2 into 4.5 MHz, we will get 9 MHz. Therefore, the number of bits n equal to log 2 of L. Substitute the value of quantization level L 1024 in the equation, we get the number of bits n equal to 10 bits. So, substitute this value of n in the required minimum bit rate RB. RB equal to NFS. That is n equal to 10 and Fs is 9 MHz. RB equal to 90 MHz or Mbps. A pulsed radar operating at 3 GHz having pulse width of 2 microsecond receives an echo from a target 10 microsecond after sending the signal. The approximate range of the target is option B, 1500 meter. Given PW equal to pulse width equal to 2 microsecond and RT rest time equal to 10 microsecond, pulse repetition time PRT equal to PW plus RT, which we will get 12 microsecond. In the radar system, the range of the target R equal to C into PRT divided by 2 meter. Substitute the values of C is the speed of light at which electromagnetic wave travel, which is 3 into 10 raised to 8 into, actually that is not plus, it is multiplication, into PRT 12 microsecond divided by 2. We will get an answer of 1800 meter. But in option there is no such answer. So approximate value of R is 1500 meter. So to get that value, take PRT is approximately 10 microsecond and substitute that value in range of the target, we get 1500 meter. Or else just choose close answer. Question number 66. The data rate of QPSK is dash as that of BPSK for the same symbol rate. That is option B, twice. For the same symbol rate RS, the data rate for different modulation techniques is shown in the table. BPSK data rate is 1 by TS, which is 1 RS BPS. QPSK is the quadrature phase shift keying is 2 by TS, which is 2 RS BPS. That is data rate of QPSK equal to 2 into data rate of BPSK. That is data rate of QPSK is twice as that of BPSK for the same symbol rate. Consider question number 67. The Norton equivalent of a network consisting of 5 ampere and 5 ohm. If 5 ohm resistor is connected across this network, what will be the Thevenin equivalent of the resulting network? Answer is option A, 12.5 volt and 2.5 ohm. A 5 ohm resistance connected in parallel with the Norton equivalent of a network consisting of 5 ampere and 5 ohm shown in figure. The open circuit voltage VOC is the VOC equal to VTH. It is 5 ampere current into the total resistance is 5 ohm parallel 5 ohm, which is equal to 5 by 2 ohm. Therefore, VTH equal to I into V equal to I into R. I is 5 ampere and R equal to 5 by 2, which we will get VTH equal to 12.5 volt. To evaluate the Thevenin resistance, open circuit the current source and evaluate the resistance across the load. That is RTH equal to 5 ohm parallel 5 ohm, that is 2.5 ohm. Then the Thevenin equivalent circuit shown is VTH equal to 12.5 volt and RTH equal to 2.5 ohm. A memory with 8-bit data bus and 16-bit data bus can store a maximum of option B 64 kilobytes. Given address bus n equal to 16 bit. The maximum number of bytes the memory can store is m is less than or equal to 2 raised to n bytes. Here n, that is address bus, equal to 16 bytes. So 2 raised to 16 byte equal to 65536 bytes or 64 kilobytes. Question number 69. What is the minimum power rating required for a transistor used in class A amplifier with a single transistor if the amplifier delivers 50 watt to a transformer coupled load? Assume that the transformer is ideal. The answer is option D, 100 watt. We know efficiency is output by input. Given output equal to 50 watt. The maximum efficiency of a class A amplifier is 50%. Therefore, 50 by 100 equal to 0.5. Minimum input required equal to output divided by maximum efficiency. Substitute the values of output and maximum efficiency. We get minimum input required is 100 watt. Consider question 70. The length of a rectangle is halved while its breadth is tripled. What is the percentage change in area? Let x is the length of rectangle, y is breadth of rectangle. Therefore, area of the rectangle equal to x into y, that is length into breadth. New length of the rectangle is x into 1 by 2 and new breadth of the rectangle is 3y. New area of the rectangle is x by 2 into 3y. Area increased is 3 by 2 xy minus xy. That is after solving we get 1 by 2 xy. Therefore, the percentage of area increased is 1 by 2 into 100. We will get 50% increase. Question number 71. Electron volt is the unit of energy. That is the amount of energy gained by a charge of a single electron moved across an electric potential difference of 1 volt is called an electron volt. It is commonly used in atomic and nuclear physics applications. 1 electron volt equal to 1.0 602 into 10 raised to minus 19 joule, or 1 electron volt equal to 1.602 into 10 raised to minus 12 erg. Joule is the SI unit of energy and the calorie is the unit of energy commonly used in nutrition. Note, watt is the SI unit of power, volt is the SI unit of potential difference, ampere is the SI unit of current. Consider question 72. Due to sun, a 6 feet man cast a shadow of 4 feet, whereas a pole next to the man cast a shadow of 36 feet. What is the height of the pole? Answer is option C, 54 feet. Given height of the man equal to 6 feet, shadow equal to 4 feet. Let height of the pole is x feet. Shadow of pole height is 36 feet. Here distance between pole and man is not given, so taken separately. Properties of similar triangles will be used, that is, the ratio of height to base of both triangles are equal. That is, 6 feet divided by 4 feet equal to x divided by 36 feet. We need to calculate the value of x. So rearrange the equation, we get x equal to 36 into 6 divided by 4. After solving, we will get an answer of x equal to 54 feet. 73. Find the value of the resistance required for Wien-Bridge oscillator to operate at 1 kHz with a capacitance of 1 microfarad. The answer is option A, 500 by pi. The circuit diagram of a Wien-Bridge oscillator is shown in figure. The phase angle criterion for oscillation is that the total phase shift around the circuit must be 0 degree. The total phase shift around circuit 0 degree occurs when the bridge gets balanced, which is at a resonance. Therefore, the frequency of oscillation is given by omega naught equal to 1 by RC, that is in radian, and F naught equal to 1 by 2 pi RC. Given F naught equal to 1 kHz, C equal to 1 microfarad. Therefore, the frequency of oscillation omega naught equal to 1 by RC, F naught equal to 1 by 2 pi RC. Therefore, we need the value of R. Rearrange the equation, we get R equal to 1 by 2 pi F naught C. Substitute the values, we get the answer of R equal to 500 by pi. Question number 74. Thevenin's theorem states that a given electrical network connected to a pair of terminals can be replaced with option B is the correct answer, a single voltage source in series with a single resistance. According to Thevenin's theorem, any linear circuit across a load can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH. If a linear circuit contains dependent source only, that is, there is no independent sources present in the network, then the open circuit voltage or Thevenin voltage will be simply 0, since there is no excitation present. Note, theorems and the circuit where they are applicable. Theorem and applicability. Superposition theorem, Thevenin theorem, Norton theorem, maximum power transfer theorem, all are applicable in linear circuit only. And Telegraph theorem can apply in all circuits. Substitution theorem also can applicable in linear and non-linear circuits. Question number 75. For a stable system, poles of the transfer function is option C, should lie entirely in the left half of the S-plane. System stability is always decided by the location of the poles irrespective of zero's location. For a stable system, poles of the transfer function should be in the left of S-plane. Consider some cases. That is, if pole location is left of S-plane, transfer function is k by s plus a into s minus a. Approximate system response is like this, that is decaying. Stability is always stable. And if the pole location is on the j omega axis, transfer function will be k divided by s square plus a square, and the system response is like this, and the system is marginal stable. If the pole location is right of S-plane, the transfer function is k divided by s minus a into s minus b, and the system response is increasing. It is unstable always. Question number 76. A silicon diode operating at a temperature of 300 Kelvin has a bias current of 2 mA. Find the dynamic resistance. Answer is option A, 30. The dynamic resistance can be defined from the VI characteristics of a diode in forward biased condition. It is defined as the ratio of small change in voltage to small change in current. The dynamic resistance is given by the inverse of the slope of VI cara. Here given bias current equal to 2 milliampere, thermal voltage Vt equal to 26 millivolt at room temperature. The dynamic resistance is given by the inverse of the slope of Vi characteristics. That is dynamic resistance Rd equal to delta V divided by delta I. That is eta Vt divided by I. Eta is 1. So substitute the values of Vt and I, we get dynamic resistance is 30 ohm. 77. The mode of the data 9, 6, 8, 9, 10, 7, 12, 15, 22 and 15 is. Answer is option A, 9 and 15. Arranging the data in the increasing order 6, 7, 8, 9, 9, 10, 12, 15, 15, 22. Here the maximum occurring terms are 9 and 15. That is both are occurring for 2 times. Therefore mode of the data is 9 and 15. Note, mean equal to sum of all observations divided by number of observation. Median equal to n plus 1 by 2 if n equal to odd number. Question number 78. Which of the following is a 16-bit register in 8085 processor? Answer is option D, stack pointer and program counter. Program counter, it acts as a pointer to the next instruction to be executed and always contains the 16-bit address of the memory location of the next instruction. It is a 16-bit register as 8085 has 16 address line. The program counter is updated by the processor and points to the next instruction after the processor has fetched the complete instruction. Next one is stack pointer. It is a 16-bit register that stores the address of the top of stack memory. The value of the stack pointer is decremented by 2 in push operation and it will increment by 2 in pop operation. Accumulator. It is a 8-bit register which contains 8 flip-flops. It can store a maximum of 8-bit data. The importance of the accumulator is that in most of the 8-bit arithmetic and logical operation, the microprocessor will always take the 8-bit number from the accumulator. 79. The diode in the circuit given below has a cut-in voltage of 0.7 voltage. If V is equal to 10 sin 100 pi t, what is the peak-to-peak voltage of V0? Answer is option D, 12.7 voltage. Given diode cut-in voltage equal to 0.7 voltage and V in equal to 10 sin 100 pi t. This is circuit. Consider case 1, positive half cycle of V, and that is V in equal to plus 10 volt. Diode D1 will be off and off because Vp less than Vin, that is minus 2 voltage is less than 10 voltage. D2 will be on because Vp greater than Vn, that is 10 volt greater than 2 voltage. Also starts conducting when Vin greater than 2 volt. Here I1 equal to 10 minus 0.7 minus 2 divided by total resistance 1K plus 1K. We get an answer of I1 3.65 milliampere. V01 equal to 1K into I1 plus 0.7 plus 2. We get 6.35 volt. Case 2. Negative half cycle of Vin, that is Vin equal to minus 10 volt. D1 will be on because Vp greater than Vin, that is minus 2 volt greater than minus 10 volt. Also starts conducting when Vin is greater than minus 2 volt. D2 will be off because Vp less than Vn, that is minus 10 volt less than 2 volt. Here I2 equal to minus 10 plus 0.7 plus 2 divided by total resistance 1K plus 1K. Here we will get after solving I2 equal to minus 3.65 milliampere. Therefore V02 equal to 1K into I2 minus 0.7 minus 2. That is V02 equal to minus 6.35 volt. Therefore peak to peak voltage of V0 equal to V01 minus V02. That is 6.35 minus of minus 6.35, that is 12.7 volt. Question number 80. The last question. The current in a coil of inductance 5 Henry charges linearly from 10 ampere to 2 ampere in t seconds. If the induced EMF is 40 volt, what is the time t? Answer is option A, 1 second. Given L equal to 5 Henry, di by dt equal to 10 minus 2 by t ampere per second. We know that voltage equation for inductance is VL equal to L di by dt. The induced EMF given is 40 volt, that is 40 equal to 5 into 10 minus 2 divided by t ampere per second. After rearranging, we get t equal to 1 second.